Hello, Algebra 2 Honors. In this video, we're going to quickly review the unit circle in radians, and I'm going to hit some really key points that will help you memorize it and will help you think in radians instead of thinking in degrees. It's really important that we are just understanding the radian system itself instead of converting from degrees to radians. Now, in class, we established that a half turn is equal to pi radians. And the way we really think in radians is to think in fractions of pi, or think in fractions of a half turn. So although 1 radian, we established that 1 radian was about 57 degrees, 57.3 or something like that. Although 1 radian is about 57 degrees, we don't really think of that as our unit that we use regularly. What we think of is 1 half turn is pi, and we think in fractions of a half turn. To help you with that, I'm going to show you how to fill in your unit circle with radian measurement, and the key is to notice where your denominators are. Denominators of 2, 3, 4, and 6 for your standard angles. And what's great is the definitions of the 6 trig functions are what you already know. We did them all in degrees. You just need to understand the angles in radians. Okay, so let's do it real quick. Now, while you're watching this video, you should have out either, I should actually switch so you can see my screen. You should have out either a blank unit circle to fill in. You can print a blank one from my shared drive. You may have a copy that I gave you. Or you can pull out this worksheet that we did, and on the last page, you will see a blank unit circle, or you could just draw one. Okay, so have something ready so you can take some notes. Okay, so how do we think in radians? Well, we did this in class, so I'm reviewing what we did in class. First off, a half turn in radians is pi. So 0 radians is the same as 0 degrees. A half turn is pi. 2 half turns is 2 pi. That's a full turn. And then the odd multiples of pi terminate on this terminal side, and the even multiples of pi terminate on this side. Then you can think in quarters of a circle or half of a half turn. A half turn is pi, or 2 pi over 2. 90 degrees, or a quarter turn, is half of a half turn. So pi over 2, 2 pi over 2, 3 pi over 2, etc. Notice our denominators of 2 are on the top and the bottom. Then you can think in dividing the circle into 6, which is dividing the half turn into 3. So I'm taking a half turn and dividing it by 3, and I get my denominators with my the denominator of 3 ends up landing on these terminal sides. Of course, that reduces to 2 pi, and of course that reduces to pi. But the way you can think in radians is just think 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5, 6, 7, 8, etc. So if I'm ever given an angle like, how about 52 pi over 3? The denominator is 3. 52 is not a multiple of 3. So I know that it has to land on one of these terminal sides. It has to be in one of those spots, and I can start figuring out where that might land. Okay. If we think in eighths of a circle, 8 pizza slices, then that's the same as 1/4 of a half turn. So we have a half turn is pi, divide by 4, we get this, and we can think in 1 pi over 4, 2 pi over 4, 3 pi over 4, etc. Notice the fractions that reduce, and notice the fractions that don't reduce. The ones that don't reduce all have a denominator of 4, So if you're given an angle that's reduced and the denominator is 4, you know that it lands on one of these diagonal lines. And I think you have the idea. We can do it in 6, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6, 7, 8, 9, 10, 11, 12 to make a full circle. 13 pi over 6 would be 13 of those pizza slices. And notice that all of these reduce. These 4 do not. So if you get a radian angle with a denominator of 6 and the fraction is reduced, you know you've landed on one of these terminal sides. Okay, let's put all that together. So how can you fill in your unit circle and memorize your radians? Start with multiples of pi. 0, pi, 2 pi. Great. Now do multiples of pi over 2, or half of a half turn. Pi over 2, 2 pi over 2, but I already have it. 3 pi over 2. Done. Now cut pi into thirds. The thirds are going to land. Oops, let me make that not quite so thick. Let's do that. The thirds in green are going to land here, here. One will land here, but we already have it with pi. Here, here. And then the last one would land where 2 pi is, but we already have that. So this is 0, pi over 3, 2 pi over 3, 3 pi over 3, but we already have it, 4 pi over 3, 5 pi over 3. Notice all those denominators that don't reduce have 3 in the denominator. Now let's do pi over 4. I'll do it in red. Pi over 4, 2 pi over 4, but we already have it, 3 pi over 4, 4 pi over 4, but we already have it, 5 pi over 4, 6 pi over 4, but we already have it. I meant to color these in red. 7 pi over 4 goes here. And 8 pi over 4 is 2 pi. That reduces. We already have it. And the last one is, let's see, I'll use purple. Pi over 6. Let's make that a little bigger. Okay, pi over 6. Okay, so pi over 6. This is 2 pi over 6, but that's pi over 3. We already have it. 3 pi over 6 is here. Already have it. 4 pi over 6 is here. We already have it. 5 pi over 6 is here. We don't have it. So I'll grab my purple. 4 pi over 6. 5 pi over 6. 6 pi over 6. Oh, sorry. I'm sorry. I think I said it wrong. Let's see. This was 1, 2, 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6 is there. 8 pi over 6, 9, 10, 11 pi over 6 we don't have yet. And we're done. These are the standard 16 angles that you have to memorize in radians. And notice where all the denominators of 2 are. Here and here. So if you get an angle that is, how about 31 pi over 2? It doesn't reduce. So I know it either has to end at the top of the circle or the bottom of the circle. And then we could just figure out which one it lands on. If you get an angle that has a denominator of 3, then it has to land on one of these green rays. If you get a denominator that ends in that, if you get a denominator of 4 in your angle, you know it's on one of the diagonals. So even if I have an angle that's like, how about 1001 pi over 4? 1001 pi over 4. I know that lands on one of these 4 diagonal rays. Okay, so once you know where all those radian angles land, you can apply the same definitions of the 6 trig functions using radians. So I've got my unit circle here, and notice, well, this is the one we did in class, by the way, but remember I had you not fill in the radian values before because we were doing everything in degrees, but all the coordinates are the same and all the definitions of this trig functions are exactly the same. So the sine of an angle is always the y coordinate on the unit circle. The cosine of an angle is always the x coordinate on a unit circle. The tangent of an angle is always y divided by x on any circle, and the unit circle as well. Okay, so if I want to calculate the sine of pi over 6, I just need to know where the pi over 6 angle terminates. And since it's sine, take the y coordinate of a half. And the answer is a half. What if I want the cosine of 7 pi over 6? Well, how you can think about this, by the way, is 7 pi over 6 is more than 6 pi over 6, which is pi. So it's more than a half turn. And so that's going to be here if you memorize where your denominators of 6 land. Okay, so that means our terminal side for this one is here. We're doing the cosine of that. So we just take the x coordinate and we get negative root 3 over 2. Okay, not bad. Tangent of, how about tangent of 7 pi over 2? Well, where's 7 pi over 2? 4 pi over 2 is 4 quarter turns, because pi over 2 is here. 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So that means our terminal side is here. 1, 2, 3, 4, 5, 6, 7. That means our point we're looking at, our coordinate, is down here. And the tangent of that would equal the y coordinate over the x coordinate, which is undefined. Okay, so all the definitions we learned last chapter for all 6. Now, of course, the reciprocals of sine, cosine, and tangent are just the reciprocals of those definitions I just gave you, as you know, because we did it all in degrees. All we're doing is we're swapping out degrees for radians, but everything we learned is the same. All right, I'll see you in class. Bye.